In this lesson, we're going to learn about dilations. We are specifically dealing with dilations when the center of the dilation is not the origin. So I'm going to type that this is the lesson title is Dilations with Points Other than the Origin. Because the center of dilation for this lesson is not the origin. And we're going to fill in some blanks here. The notes start with this sentence. To dilate a figure when the center of dilation is not the origin. Okay, and in big black letters with underline, they're bold, you cannot multiply the coordinates of the vertices of the pre-image by the scale factor to get the coordinates of the image. So there was a trick for when the center was the origin. You could just multiply all the points. This says scale factor. When the scale factor, cannot use the scale factor and just start multiplying. Instead of doing that, you're going to have to count the horizontal and vertical distances from the center of dilation and multiply those numbers by the scale factor. That sounds really complicated, but I promise it's not that bad. We are going to have to do a little bit of figuring out. Okay? Alright, so let's start with this first example. It says, graph the dilation. The center of dilation is -6, -6. And the scale factor is 3. So I need to give you some information. Let's say that we have triangle ABC, and A is located at -5, -1, B is -3, -5, and C is -1, -2. All right, -5, -1 is A, -3, -5 is B, -1, -2 is C. Okay. All right, so the center of dilation is -6, -6. So we're going to be counting the horizontal and vertical distances from this point to each of the other points. So each of the vertices will count from the blue. So let's see, how do I get from this blue point all the way to A? I go up 1, 2, 3, 4, 5, and right 1. I want to write that down. Up 5 and right 1. Well, guess what? To get to A prime, I'm not going to go up 5 and right 1 because I'll end up at A. I need to go triple that distance. So I need to go up. 5 times 3 is 15. 1 times 3 is 3. I need to start at this blue point, go up 15 and right 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 1, 2, 3. And that is A prime. Okay, so let's do that again. Let's go to B. How do I get from this blue point to B? I go up 1 and over 1, 2, 3. Let's write that down. Up 1 and to the right 3. So I want to do triple that. Up 1 times 3 is 3. 3 times 3 is 9. When I go up 3, 1, 2, 3, and over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's B prime. And then to get to C, how do I get to C from here? 1, 2, 3, 4. Up 4 and over. 1, 2, 3, 4, 5. Up. I remember I went right 5, but I can't remember how many it was. Let's count again. 1, 2, 3, 4 up, and 1, 2, 3, 4, 5 to the right. Okay, so you're going to do the same thing. Not going up 4 and right 5 because that'll be C. I need to go triple that. 4 times 3 is 12. 5 times 3 is 15. So, from the blue dot, I need to go up 12 and right 15. That is so many points. Okay, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 10, 11, 12, 13, 14, 15. I sure hope that I counted correctly. Let me check my answer key for just a second. Yes, all of this looks beautiful. Okay, so all I need to do is connect the dots. Alright, so just take a look back, take a step back and look. Is this new figure, the image, 3 times the size of this one? Yeah, it is. If I connect the dots, do A and A prime go in the direction of this dot? If I keep going, will I connect all 3 dots together? Will I connect all 3 dots together? Then I have done it correctly. Okay, let's go ahead, scroll down, and look at this last example. Okay, this one says graph the dilation. The center of dilation is negative 8.5. The scale factor is 1/4. So this time, are we dealing with an enlargement or a reduction? This is certainly a reduction because this number here is less than 1. Okay, so let's start with E, F, and G. E is 0, 9, F is negative 10, 1, and G is negative 8, negative 1. So go ahead and graph 0, 9, negative 10, 1, and negative 8, negative 1. Okay, all right, the center of dilation is negative 8, 5. 1, 2, 3, 4, 5. All right, so I want to count to see how far do I need to go to get to each of the points. We'll start in order. So to get to E from the purple dot, I go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4 up, and 8 to the right. Okay, so to get to E prime, I'm going to not go up 4 and over 8. I'm going to do a quarter of those distances. So divide each of these numbers by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So we're going to go up 1 and over 2. From the purple dot, up 1 over 2, guess what? That is E prime. Okay, let's go ahead and count. To get to F from the purple dot, I need to go down 1, 2, 3, 4, and over 2. Down 4 and left 2. So to get to the new point, F prime, I need to divide each of these numbers by 4. 4 divided by 4 is 1. Go down 1. 2 divided by 4 is a half. Right 1 half. 1 half. So down 1 and then, it's left 1 half. Down 1, left a half. Ooh, that is really close. All right. And then the last one is G. How do I get from the purple dot to G? It looks like I got to go down 1, 2, 3, 4, 5, 6. Down 6. So instead of going down 6, 6 divided by 4 is 1.5. And if you're not sure, use a calculator. I have one right next to me. 6 divided by 4 is 1 half. So 1 and a half, 1 and a half, 1.5. So instead of going down 6, I'm going to go down 1.5. 1.5 is here. That's G prime. And then you connect the dots, and it's a little bit ugly, but if I had connected them in a nice, pretty way, see how small this triangle is? It is 1/4 the size of the triangle that we started with. Okay, and here is a third example. The third example says graph the dilation. The center is 0, -2. The scale factor is 1/2. This is just another example. So we're starting with MNOP, and this is going to take a few minutes. M is 4, 6. N is -4, 5. O is -5, -4. And P is 9, -7. Go ahead and graph those. 4, 6, -4, 5, -5, -4, and 9, -7. Alright, this is a quadrilateral. There's no specific name for what type of figure this is. It just has 4 sides. I tried my best to draw it pretty. Okay, so the center of dilation is 0, -2. Go ahead and mark that. And then count how far do I go up and over to get to each point. So M, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4. Up 8, right 4. To get to N, I'm going to go up 1, 2, 3, 4, 5, 6, 7, and over to the right 1, 2, 3, 4. Excuse me, that was left 4. Up 7 and left 4. Okay, to get to O, going down 1, 2, and over 1, 2, 3, 4, 5. Down 2 and left 5. And then the last one, to get to P, we're going down 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 5 and right 9. Okay, then you take each of these numbers, and what do you do with this 1/2? Each of these numbers gets divided by 2, aka multiplied by 1/2. So 8 divided by 2 is 4, 4 divided by 2 is 2. 7 divided by 2 is 3.5. 4 divided by 2 is 2. Okay, 2 divided by 2 is 1. 5 divided by 2 is 2.5. 5 divided by 2 is 2.5. And 9 divided by 2 is 4.5. Okay, so you're going to use all those numbers, and then we're going to plot the points. Okay, so I've got to go up 4, right 2. 1, 2, 3, 4, 1, 2. That will be M prime. Okay, I'm going to go up 3.5, 1, 2, 3.5, and then left 2. Okay, that is going to be N prime. Ooh, so messy. And then I'm going to go down 1 and left 2.5. And that's going to be O prime. And then for P, I'm going down 2.5 and right 4.5. 1, 2, 3, 4.5. It's so messy. Okay, and just for your reference, just in case you would really like to have this because my drawing is a little bit messy, M prime is now located at 2, 2. N prime is -2, 1.5. Okay, O prime is -2.5, comma, -3. And P prime is 4.5, comma, negative 4.5. Okay, let's go ahead and look at one final example. It's a slightly different type of question. Okay, example 4 says a dilation has occurred. Determine the center of dilation and the scale factor. Okay, so to find the center of dilation, you are going to be connecting some things. You're going to connect O and O prime. So this might take me a moment to get my ruler oriented the way I need it to be. So you see O and O prime. We want to connect those dots. It's going to take a second to get this the way we need it. Okay, that's the best I can do to connect those dots. Okay. All right, and then, ooh, that's good. And then let's see if we can connect N and N prime. Let's try that. A little tricky. I think that might be the best we can do. Okay. Let's try that one again. One more time, we'll try that one again. Okay. And then the final one, we could connect M and M prime, since my ruler is a little bit tricky to use on this computer screen. Let's do M and M prime. But generally speaking, you should have been able to find the answer already. Just based on the two purple lines, wherever they cross, that's going to be the center of dilation. Let me see if I can draw this. Get these two dots to connect. Okay. Now, as you can see, my three lines are not perfectly connected here. However, I can tell you if you used a ruler and were very careful on your own paper, you would have found that 2, 3 was actually where all three lines connected. This was the best I could do with the technology that I have. 2, 3 is actually where all three of these lines are going to intersect. So your center of dilation is 2, 3. Okay, that's part of the answer. The other question you're trying to answer is the scale factor. So let's talk about the scale factor. I can figure that out a few different ways. Why don't we talk about one way? So I would like to make some comparisons. I really just need to look for a couple of measurements, maybe even just one. Okay, so what I'm going to do is I'm going to look at O and M, and I'm going to look to see how many units up do I need to go from O to get to M. So I'm going to measure the height of this triangle. I see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 boxes tall. Okay, and then to get from O prime up to M prime, how many boxes tall is that? That looks like 1, 2, 3, 4, 5 boxes tall. Okay, so 5 and 10 have a very clear relationship. We start with the number 10 and we end up with the number 5, right? Here's the Pre-image, here's the image. From 10 to 5 is dividing by 2. That's a scale factor of a half. So those are your two answers for this question. Okay. We're going to look at two more, and then we are finished with dilations. Dilate the figure using a scale factor of 3 and a center of dilation -3, -4. Alright, so let's mark -3, -4. It's here. To get to E, I need to go up 1, 2, and over 1. To get to F, I have to go up 1, 2, 3, 4, and over 1, 2, 3, 4. To get to G, I have to go up 1 and over 1, 2, 3. Alright, so we're going to use those numbers. We're going to figure out what happens when you have a scale factor of 3. Multiply by 3. 2 times 3 is 6. 1 times 3 is 3. 4 times 3 is 12. 4 times 3 is 12. 1 times 3 is 3. And 3 times 3 is 9. Okay, so we're going to use these numbers, and that's how we're going to graph our image. So go up 6 and right or left 3. 1, 2, 3, 4, 5, 6. 1, 2, 3. That's E prime. And F prime, we're going to go up 12 and right 12. Okay, so we're already at 4. So up 4 and then 8 more. 1, 2, 3, 4, 5, 6, 7, 8. And then over 12. So we've gone over 3 and then over 9 more. Maybe here. Alright, that's F prime. And then G prime, we're going to go up 3 and right 9. Okay, so this is right 3. We need to go 6 more. Alright, this is G prime. Alright, practice 2 says a dilation has occurred. Determine the center of dilation and the scale factor. So I'm going to go ahead and not use my ruler since this picture is quite small. I'm going to try my best to connect the dots freehand. Let's try that again. Okay, Q prime, and then the R prime, R and R prime, and S prime. They seem to connect over here, and I can tell you for sure that this is 6, -5, and I think freehanding here I did a better job than using the ruler. So the center of dilation is 6, -5. Now to find the scale factor, you can count to see how tall is this triangle from Q to S. 1, 2, 3, this is 10 plus, this looks like 5 more, so that's 15 units tall. And over here from Q to S is 1, 2, 3 units tall. Alright, so we're going from the number 15 to a height of 3, which is dividing by 5, so that means your scale factor is a fifth. Thank you so much for watching.